Hello everyone, it's October the 10th. I didn't do the live stream yesterday because I was in the ER. My cat has some issues. So I had I had the idea that ER you have to wait. So I decided to do yesterday's LeetCode. That was yesterday's LeetCode. That was yesterday. So I did it on my freaking phone. So I coded this up on my phone. I think this is the first time. Hopefully the last time I have to do this. Things are very wonky the way you type on your phone. You try to type these things. It's definitely not a very good experience. But yesterday's problem is pretty easy, so everything worked out. I forgot to upload. Everything worked out. So yeah, that's that. Anyway, let's do today's. So are we still dealing? Yeah, we're still dealing with magic, casting, this type of stuff. Maximum total damage with spell casting. A magician has various spells. Given an array power where each element represents the damage of a spell. Multiple spells can have the same damage value. It is known fact that if a magician decides to cast a spell with a damage of power I, they cannot cast any spell with a damage of within 2. Each spell can be cast only once. Return the maximum possible. I think it's another DP-ish question. So basically at each position we need to decide whether we want to cast it or not cast it. So 1, 1, 3, 4. Each can cast only once, but it never says we have to cast in order, so we just sort it, right? And then we probably have the binary search, right? So let's say if I don't cast this one, then we just move on to the next one. If I cast this, then the next one I can cast is they cannot cast any spell with a damage of this, this, or this. So basically I can only cast -1, smaller than that -1, or larger equal to 3. No. So actually smaller than, it's larger than. So if I do this, I can only do this or this. And why would I cast a small one? So I should only cast something bigger, right? So yeah, this doesn't make any sense. So we'll only cast this. Under 3, I can only cast 1. And then once this is done, and that's it. Because we go from small to large, so it doesn't really matter. We don't have to go back. So this will be 1 plus 4. That will be 5. And this will be 1 plus 4 equal to 5. This will be... How'd you get 6? Oh, you can cast the same. Oh, my bad. Holy crap. So either equal to 1. Oh. I see. Then we do a counter. 1 is 2, 3 is 1, 4 is 1. So it'll be sorted, right? Actually, it doesn't even matter. Does it matter? Sorted? So we need to know what would be the next one to cast. Well, technically, if we have a lot more, we can cast any one of them. So I'm not sure, but basically they can all be cast at once. Yeah, you can always cast them at once. It's like just freely given, right? Freely given. You don't have to worry about it. So yeah, so basically, do you want to cast 1? If you don't cast it, then we'll cast 3. Right? If you cast it, then we'll say, do you want to cast? We need to find a maximum. So at I, so we say DPI. So we get assorted, right? So the DPI is the max total in spells, power, unique powers, right? Unique powers I to the end. So given the current, I will just, binary search. You don't need binary search. Well, how do you not need binary search? We need binary search to find what's the next one. Upper bound, right? We need upper bound to find. Can I use upper bound on a map? Oh, you can. Holy crap. Oh, wow. Upper bound. What does it give you? Oh, darn. All right. Yeah, 40 will give you end, which is perfectly fine by me. Okay, so we do that, we do the upper bound, and we know it's, oh, but we need index. We need index, don't we? We need index. Now, if we go from large to small, we don't have to. We don't have to. How to iterate a map? How to iterate a map from largest key to smallest key? A reverse iterator. Oh, we can use, oh wow, R begin, R end. Okay, so R begin, what we can do, because it's the largest, it's just by itself, right? We don't get anything. And then the next one will binary search. The next one will binary search. Right, next will binary search the largest. And yeah, I feel like this shall work. I think this is for 11. Use an ordered map to get the count, get the frequency of each power. All the powers, right, of the same value can be taken together. Right. This is a freely given option. Then we consider a sorted list of unique powers. dp. You need powers, and define dpi to be the max damage possible using unique powers I to the end, right? I to the end. However, we don't need to bother with a sorted list. We can use the ordered map directly and binary search to find the iterator, right? To find the iterator for the dp. Alright, so we need, I think this is just a map. So this will be counter. Call it dp. Far away from me. Wait, dp? No, power. Plus. And then, oh, let's not do that. Let's go long. Okay, then yeah, long rest equal to 0. Also, we will iterate dp from large, iterate the counter, right, from large to small. This way, we only need to consider the plus option when casting the next spell. Okay, so for auto it equal to dp.r begin it. Okay, actually that's smaller than that, right? Not equal to, my bad, not equal to dp.r end it plus, right? Yeah. Okay, so we say auto, this is it, and the binary search it. Upper bound it equal to dp.upper bound it first plus 2. Okay, and if upper it is equal to dp dot and then dp so upper it doesn't, you don't have any, so the current it first shall equal to it first multiplied by it second. Right, it's second. Actually, this is what all of them should do. So we do this. I'll do this first. Yeah, we can always cast the same power spell. Right. So yeah, we update this one first, and then we check if they're upper bound. If we find some, then, and everybody is larger than 0, so we can always add. Yeah. Then dp it first plus equal to upper it second, and then res shall equal to maximum res and dp it first. Actually, here we're not updating, so I should do that. That looks okay. Yeah. Is that updated? And then move on. And then we just keep going until we hit the first, and then we'll return res. Alright, let's see. Looks good. Far away. Oh, it does not look good. Alright, we have an issue. We don't have the sort, but okay, so we have 1, 3, 6, and 7. So here is 7, 6 is gonna be 6, 3 plus 2 is 5. Oh, should be 10. Yeah, you're right. This is not the largest. If we don't take it, like if we take it and then if we don't take it, yep, hold on. Yeah, this is some issue. So we do this first, auto it. So this is option 1. Do not take the current potion. Right? Do not take the current spell. Do not use the current spell. Do not use the current spell. Then we shall just set int current shall equal to the next spell, which is it plus 1. Otherwise, it's going to be 0. So the equal to it is equal to dp dot r begin if it is 0. Otherwise, it plus 1 second. Right. So option 1. I cannot do that. How do I move to the next iterator? How to move to the next iterator? Plus plus. Oh, std next. Okay, std next, my bad. So we had to std next it. Does this one change it? It still points to A. Good. So this is the current, right? Option 2. Use the current spell. So, and actually this should be option 1. This is option 2, right? Oh, long, man. This should be long. Right, option 2, and then this, and then this is going to be option 2. Just realized I don't need this, right? And then DP, so option 1, option 2, combine the 2 options. And then combine the 2 options, it's going to be dp it first shall equal to maximum option 1, option 2. Now technically we can avoid some, but I guess it's fine. And then after that I'll do this. Okay. So now let's read this one. That was an oversight. Pretty serious oversight, actually. I should have known better. And I couldn't do this. Oh yeah. If it's the... or begin. Wait, hold on. It's not the same? Or begin. Because we're in reverse, maybe this is what we need. I'm just guessing. Do you have to go the other direction? Yes, because you're reverse, right? You're in reverse, so which means the next is going to the left. If you want to go right, you have to do -1. Interesting. You learn new stuff, and we are not very good in time. I guess it's okay. I don't know. I mean, there could be many different reasons for the performance to be a little bit subpar. Let's see, what's the tutorial say? DP, I got a map, I got this, I got a pair. What do you need a pair for? I think it's to sort, but I don't see sort. Pair of this and this. Do count. And I will push back. So this is power. Okay, this is the power and this is the count. All right, so we do that and we have, yeah, what the hell is this? Vector long. I think that's probably the DP table. And then for this the sort happens because of this. It's okay. So okay, this is sorted based on the power. And then, oh, I see. It's the 2 pointer again. Yeah. So you gotta sort it, and then so for something, so I just need to keep 2 pointers. So when you move. So yeah, so I have 2 pointers. 1 pointer move from right to left. Once they hit something that it's good, So every time we try to check, and if it's larger than this, right? I mean, I'm going right to left, so I'll always move until you move to a point which is like if it's larger than, then we always move to the left until we cannot. Then I'll move one back, and then we'll do it. Right? And then we'll do it. And then we will move again. Right? And then we'll move. And I say, oh, cannot move. And then we go back. Yeah, okay, actually decide. Yeah, I know what this one is. I'm too lazy to implement again, but this is not the optimal. This, I know why this one's faster. Yeah, this I guess is just like when you go to the end. Yeah, why do you do this? I don't understand. Yeah, but I know, yeah, this can be done without binary search. But we already did, so yeah. Anyway, that will be it. I'll see you guys.